In the first lesson of solving our polynomial equations unit, we looked at solving quadratic equations and looked at about 3 different methods of how we can solve a quadratic equation. We're going to use mostly factoring in general for solving polynomial equations. If you move on to advanced functions, we learned something called the factor theorem, which can also help us solve polynomial equations, but that's beyond the scope of this course. So if you need to, you can get the summary sheet out that we did earlier for our factoring. Now, in the first question here we want to find the value of x that's going to make this equation equal to 0. Now, when we factor, we always want to look for a common factor first. And I'm noticing that x is common to every term. So I'm going to common factor x out of every term. And what that leaves me with is a nice simple trinomial inside that bracket. So here I would look for two numbers that are going to add to -1 and multiply to -2. And -2 and +1 would be those two numbers. So because it's a simple trinomial, I can take those values and insert them in the brackets, and we end up with x times x minus 2 times x plus 1 multiplied together to equal 0. Now, the only way that the product of those three things is going to equal 0 is if one of those three things is actually a 0 itself. So either x equals 0, x minus 2 equals 0, which then gives us x equals 2, or our last one, x plus 1 is equal to 0, which gives us x is equal to -1. So those are our three possible values for x that would make this equation true. All right, part B, there is no common factor because I have looked first for that. It is a trinomial, it is a simple trinomial, and it follows that format of ax squared plus bx plus c. It's just a little bit different because it's ax to the 4 plus bx squared plus my constant term there. All right, so I'm still going to look for two numbers that will add to -10 and will multiply to 9. So -9 and -1 will do that for us. And then because it's a simple one, I'm going to break down my brackets, but instead of just having an x and an x, I need an x squared and an x squared at the beginning of my two brackets so that when I multiply those together, I get my x cubed out of that. And I'm just going to repeat that 2 to make it actually look hopefully like a 2 there. All right, and because it's a simple one, we can go just x squared take away 1 and an x squared take away 9, and that has to equal 0. Now within those two brackets, both of those give us two terms which are both differences of squares. So we know that if I square root the first, I would get an x, square root the last, I get a 1, and we're going to have two brackets that look the same except they're conjugates of each other. Same with the x squared minus 9, that's a difference of squares. Square root the first, we get x, square root the 9, we get 3, we make 1 plus and make 1 minus. All right, at this point we have four things being multiplied together to give us an answer of 0. The only way that will work is if one of those four things is actually equal to 0. So either x minus 1 equals 0, which gives us x equals 1. We're going to have an x plus 1 equals 0, which gives us x equals -1. We would have an x plus 3 equals 0, which gives us x equals -3. And our last one is x minus 3 equals 0, which gives us x equals 3. So those are our four answers for this quartic equation. All right, part C here. Always, always, always look for a common factor first. Both of those numbers can be divided by 2. And when I divide them by 2, I get an x to the 4 minus 81. Now that is a difference of squares in there. I can square root the first and get an x squared, square root the last and get a 9, and make 1 a minus, and make a second bracket the conjugate of that one, which has a plus in between. Now we have the product of three things. 2 is just 2. It will never equal anything other than 2, so I can just ignore that piece. Oh, but wait a second. This is a difference of squares. We should factor it as a difference of squares. So let me do that there. I would have my 2 still out front. We're going to have an x minus 3, x plus 3 to factor the x squared minus 9. And the other bracket here, this is not a difference because it has a plus in between. When you have a plus between two squares like that, it will not factor any further. So again, 2 is just 2. It will never equal 0. We have x minus 3 equaling 0, which gives us x equals 3. We have an x plus 3 equals 0, which gives us x equals negative 3. This, if we try to set this equal to 0, we would have x squared equals negative 9, and then when I try to solve that for x, I would have to do plus or minus the square root of negative 9. That has no solution. So there are only 2 x-intercepts for this, or 2 solutions for this quartic. This has no solution. You cannot square root a negative number in the real number system. Okay, part D, common factor first. I do not like working with a lead coefficient of a negative in front of my x, so I'm going to common factor everything by negative 1, first of all, and then I'm going to work from there. Okay, and then I have 4 terms here. I'm going to see if I can pair things up for a common factor here. So if I look at these first 2 terms, actually I might make that a square bracket here. First 2 terms, I see x squared is common to both of them, and that leaves me with an x take away 2. And out of the last 2 terms, I notice I could common factor negative 4 out. And again, I have an x minus 2. And that's a good thing, because then I'm actually setting this up for grouping for a common factor. So x minus 2 is my common, and we have an x squared minus 4. And that x squared minus 4 is a difference of squares. And that becomes an x minus 2, x plus 2. Difference of squares, I'm going to have conjugates. That gives me 3 factors, but notice these 2 are the same. So they both only give me an x minus 2 equals 0 or x equals positive 2. I just skipped a step there because I'm running out of room. And this would be x plus 2 equals 0, which means x equals negative 2. So this has 2, this cubic has 2 solutions to it. All right, moving along here. Part E, again, I look for a common factor. I see x is common to all terms. I almost didn't catch that one. That gives us this. And then, because there's 4 terms left, I'm going to try pairing them up for a common factor. The x just goes along for the ride here. I'm going to take x squared out of the first 2 terms and get an x minus 1. I would take a minus 3 out of the last 2 terms and get an x minus 1. And now we have x times, the x minus 1 is common to both, and then we have a bracket of x squared minus 3. 3 is not a perfect square. It looks like it should be a difference of squares, but it's not a perfect square. So I'm just going to solve from here. Either x equals 0, x minus 1 equals 0, which means x equals 1, or we have x squared minus 3 equaling 0, which means x squared equals positive 3. I can square root a positive 3, and when I do, there's 2 answers to it. Positive root 3 and negative root 3. So there's actually 4 x-intercepts here. 1, 2. This was really 2 x-intercepts. The positive square root of 3, or we get x equals negative square root of 3. All right, the last one here. I see I have a common factor of x squared. I'm going to pull x squared out of everything, leaves me with an x squared minus 5x plus 1 equals 0. I have a nice little simple trinomial in that bracket. I would look for 2 numbers that add to negative 5 and multiply to 1. And the only thing that multiplies to 1 is 1 and 1. There's no way that's going to add to negative 5. So what I need to do with this is use the quadratic formula on it. But while I do that, or before I forget, I'm going to have this x squared equaling 0, which gives me x equals 0 as one of my solutions. My other one would be x equals negative b plus or minus the square root of b squared, I'm just going to square that, minus 4 times a times c. Those are all ones there, and I've kind of run out of room. Oh, I can move that over. All divided by 2 times a. So I'm just using the values out of this part right here, my a, b, and c there. So that gives me x equals 5, negative negative b, plus or minus the square root of, now 25 minus 4 would be a 19, and then that's all divided by 2. So my two values out of that would be x equals 5 plus the square root of 19 divided by 2, or x equals 5 minus the square root of 19, all divided by 2. If I take those to decimal values, which I have not done, so I got to do that, square root of 19 plus 5 equals divided by 2, I got approximately 4.68, or x is approximately equal to 5 minus the square root of 19 equals divided by 2. I got a 0.32 approximately out of the second one. So those are my three x-intercepts for that quartic. Now this one is, if we look at the related function, the y equals x to the 4 minus 5x cubed plus x squared, this x-intercept would be a bounce, whereas the other two would be cut-throughs. Okay.